All right. Good morning, ladies, gentlemen of YouTube. I only wish I could composite the pictures from this morning and give you an idea how much the sand battery kicked it over the top. And it only ran 3, 4 hours. So this is kind of preemptive because I just think that I fixed or solved the not chrome wire failure overheating issue. I'll know today it's going to be sunny. I'll have it on all day. And if it can run all day, it should be able to just run all day like that. Is the but as far as the height, right now it's only about 8 inches tall. So I really can't do any like real measurements or nothing like that with it. But I did kind of sketch this up as a doodle for all y'all that like to follow what I do and kind of mimic it and improve on it. But here you go. Is I would say two aluminum fuel tanks that are new, just scratch and dents. They sell them fairly cheap. I seen some the other day, 175 for one, and like 225 for the other, and expect it to be equal. Like the cheaper they are, like they might be missing parts or they just might not be finished, kind of deal. Other ones are just scratched, and nothing more than a scratch that'll never buff out, and they sell them really cheap. But I've picked on old fuel tanks for a long time. I don't pick on them if they've ever had diesel in them. That's just nasty. But the new used or used new or however you want to say it, new salvage, I do that quite a bit. But like a 22-inch inside diameter tank, like a 26 outside diameter. Normally, the outside is going to tell you how big you can build it because they're not going to be very long. They're for just different trucks use different size fuel tanks, but you should be able to fit the outside. If you need one big, a word to the wise is look up a pontoon place, a place that makes those boat logs for the pontoons. They can hook you up to like 30 something inches. You can get a lot of space between there. And if you got a pontoon place, they could probably do both, and you could get the inside diameter, same, no different. I only drew one of these just so it didn't look so convoluted you couldn't understand. But where the copper hits the element at the bottom, it'll come up, go over, down, and back out. This is not made for convection like the one I made already. If you made it short enough, like a straight 24-inch riser, it would be more than enough. But this is for a bigger idea, is what I'm trying to tell y'all. Is the air is I would force it in like with a air dryer, blow dryer kind of deal, just to keep the air flowing across the element. Sandwich the element inside of. Let me back up and see if I can't find these things. Like they make cake pans. Oh no, I don't have it. Yeah, I do. It's up here. And they make stainless steel cake pans and stuff like that, y'all. But they make these real thin stainless steel. This is for like to cover an element on a stove. It's not thick or nothing like that. But that's just enough to keep the air or the coil encapsulated. So and I would strongly suggest when you fill this is fill it up inverted and have a way to pick it up and rotate it because it's going to be several hundred pounds. The ugly Iron Man, the concrete gasifier that's behind me, that's about 3,700 by adding up all the concrete bags and sand that I used. It's quite a bit of weight. Um, Something small, when I say small, like 2 foot in diameter by 3 foot tall, is still going to be several hundred pounds. Like not 1,000, but several hundred. Just put that into perspective. But once you get that kind of thermal mass heated, it's going to stay warm. That's what kicked it over the top here last night. Um, just that little bit, and it only got it up to about 100 degrees on the outside surface of the battery, it heated up the ugly Iron Man like a sand battery, got the outside up to about 100. You cannot escape 3,700 pounds of mass that's at 100 degrees. It's like this floor. When the floor gets up X amount of degrees, 80, 90 degrees, you can't get away from it. You got to open up the front door. That's the only way to get away from the heat. Um, or have an air exchange kind of thing that I was talking about. I've not built one yet, but that's coming next because this can be done with relatively small amounts of energy that would otherwise be wasted through the day with solar. That's the cool part about this is this is not like off the batteries. This is not nothing like that. This is just straight. Otherwise, use it or lose it. Solar energy through the day. That's what this is. Um, but like I was saying, is there'd be multiple of these little heat riser pipes coming up off the element. Um, Down at the bottom, you could cross drill it and insert a copper, and these need to all be copper. It's not negotiable. This trick works because of dissimilar metals. The pipes need to be copper. The outside of the jacket needs to be aluminum or stainless steel. The plates down here that come in contact with the copper and the element need to be stainless steel. Um, the air intake could be aluminum if it has, if you need it, that's fine. But just make sure that it's like a Venture, so the the blow dryer is like blowing a concentrated here, and then the air duct is here, so it pushes more air than just what the blow dryer can do. Is what I'm trying to get at. But to force the air up and through, the heat is going to cause it to rise. What's going to stall is when it's trying to overwork. That's where you're going to need the air. Is what I'm trying to get at. But one time up, it would overwork too quickly, or it would not use up enough of the heat. Is what I'm trying to get at. You could cross drill it several times if you did it a straight, shot up, and that would probably help. Is what I'm trying to get at. It just lower the air pressure. You could do it just straight up, cross drilling it and inserting like copper tubing crossways in there, in the not connected by air, just so the heat, because the copper is super conductive. The thermal K on the copper is really high. But so it'll radiate the heat out into the concrete mass. And use sodium silicate, if I've not already said it. It's the same stuff you use to harden the sand to do sand casting. It'll take the heat. It will come apart, especially when it's hot. So you couldn't open this thing ever hot or nothing like that. But why would you? I couldn't imagine. It's going to be upwards of 1,000 degrees inside this, in that range. 700-800, easy peasy is what I'm trying to get at. A lot of these other ones that are using the electric coil, the reason that they're limited to like 300-400 degrees, 500 degrees is the PID, that the thermal connection that they're using is stopping it so it doesn't burn up the element. Yesterday I was doing it in that little test on top of the Ironman. It was wide open for the length of the day with no detriment. It was because it was circulating the air with convection. The big aluminum pipe was going down to the side of the element, allowing the air to cross and then go out through the riser pipes. And like I said, you could do the same thing, but then you would be limited to like 8-10 inches of concrete mass, 12 inches. If you do a loop in the pipe, you can get up to like 24 inches. This is just to make it bigger, y'all, is what I'm trying to get at. And you can always recover the heat by putting the shell over the top, forcing the same air up and through. Whether it's being heated or not, it'll force the air out the bottom to recover the heat from the unit with the same dryer, just with no element being on. And you can have coils of copper. That's what I drew here, like a little rib cage. But that's so you can recover your hot water for your floor, your whatever you want to do, because it's not going to really that water is going to be roughly the same temperature as that outside surface of the concrete. The I tested. I can't like get up and down this morning. I'm still sore from digging, y'all. I'll be honest. Is the I can get up and down, but it's a lot of squealing involved. I did some temperatures of that core battery earlier. The outside of the ugly Iron Man concrete is 100 degrees, 98 something. The sand temperature in the core is still about 114, 115 degrees, and I was shooting the laser inside the copper tubing. That was the best I could do. I don't have a pin to know exactly what the core temperature is. But like I was saying, it was only on for about 3 hours yesterday. And that's a massive amount of thermal mass that it heated up that quickly. This would be the next evolution in what I've learned to save the element, to allow it to run at full tilt, but still save the element so it's not hurting it. Because the nichrome wire should be able to run at full tilt 24/7, 365 for X amount of years. It has no problem, no issue with running at that temperature. It's when the saturated temperature gets it too high, then the nichrome wire fails. That's the deal. This keeps the even with straight pipes, it keeps the flow, the airflow, because you're using the copper. It's going to pull more air than the aluminum. Never mind, y'all. Just do it this way; it'll work. Is what I'm trying to say. I can't put it in words any better. My brain ain't working this morning. All right, we're going to keep this one short. Hope you all have a good one, better one. Keep the faith. We can do it. We can live off the sun, and we don't have to do what they say, because we can live anywhere we want, and we can live off the sun. Good thing. All right, bye.